Hello, and today I am going to be presenting a short video on deriving the rate equation for mixed inhibition. I tried multiple times to write this down, explain, and kind of show what I was doing while doing it, but for some reason I just can't think that way, and I was messing up too much, and I tried way too many times, so I decided to just get the whole derivation down on paper and explain the way through it. So with that said, let's begin. So if we start with the equation for the concentration of enzyme total, which is equal to the concentration of the enzyme plus the concentration of the enzyme substrate complex plus the concentration of the enzyme inhibitor complex plus the concentration of the enzyme substrate inhibitor complex. And as we know, enzyme plus substrate goes to an enzyme substrate complex with K on and K off. It can go the other direction. And the enzyme substrate complex gives us enzyme plus product. So with mixed inhibition, an inhibitor can be added in two places to this equation. So an inhibitor can be added to the reactants of this part of the equation right here. So we would have enzyme plus inhibitor plus substrate, and this would go to an enzyme inhibitor complex plus substrate, or the inhibitor can be added to the reactant side, the enzyme substrate complex. So that would be the enzyme times the substrate plus the inhibitor, which would go to an enzyme substrate inhibitor complex. So from these equations, we can find the Km. The Km is equal to the concentration of the enzyme here times the concentration of the substrate here over the concentration of the enzyme substrate product or complex, which is right here. And similarly, we can also find two equations for the K value of the inhibitor complex, which is Ki. So Ki is equal to the enzyme concentration right here times the inhibitor concentration right here over the enzyme inhibitor concentrate, or the enzyme inhibitor complex concentration right here. But the Ki using the other equation is also equal to the enzyme times substrate complex concentration right here times the inhibitor concentration right here, all over the enzyme substrate inhibitor complex, which is right here. So now that we can have these, that we have these equations, we can rearrange them for the K values to solve for variables from the E total equation. So if we take the Km expression, which is the enzyme concentration times the substrate concentration, all over the enzyme substrate complex concentration, and we multiply that by the denominator and divide that by the Km, we have solved for the concentration of the enzyme substrate complex, which is equal to the concentration of the enzyme times the concentration of the substrate all over the Km value. In a similar way, we can do the same thing to the both Ki expressions. So if we multiply here by the denominator and divide by Ki1, then we will get that the enzyme inhibitor complex, the concentration of it, is equal to the concentration of the enzyme times the concentration of the inhibitor all over Ki1. And not to be repetitive, but we get the same thing here. If we multiply by the denominator and divide by Ki2, we get the enzyme substrate inhibitor complex concentration is equal to the enzyme times the substrate complex concentration times the concentration of the inhibitor all over Ki2. So now that we have rearranged the K expressions, we can substitute each into the E total equation from the beginning. So if we go back to the E total equation from the beginning, we have solved for ES right here. We have solved for EI right here. And we have also solved for ESI right here. So if we put these three things into the equation in their place, we get this new concentration of E total equation, which is equal to the concentration of free enzyme plus the concentration of the enzyme times the concentration of the substrate all over Km, plus the concentration of the enzyme times the concentration of the inhibitor all over Ki1, plus the concentration of the enzyme substrate complex times the concentration of the inhibitor all over Ki2. However, this final term can be further simplified. So by doing this, we would get the concentration of E total is equal to the concentration of the enzyme plus the concentration of the enzyme times the concentration of the substrate all over Km plus the concentration of the enzyme times the concentration of the inhibitor all over Ki plus the concentration of the enzyme times the concentration of the substrate all over Km times the concentration of the inhibitor all over Ki2. So what we did was, we know that the enzyme substrate complex is equal to the concentration of the enzyme times the concentration of the substrate all over Km. So if we plug this in right here, we get this times the concentration of the inhibitor over Ki2. So now, since each expression within the equation relates to the concentration of the enzyme, we can factor out the concentration of the enzyme to simplify. So by doing this, we would get that the concentration of enzyme total equals the concentration of free enzyme times 1 plus the concentration of the substrate over Km plus the concentration of the inhibitor all over Ki1 plus the concentration of the substrate all over Km times the concentration of the inhibitor all over Ki2. And now, since this is a rate equation that we are trying to derive, we will need to relate the following equations. So V naught equals K times the concentration of the enzyme substrate complex. And this is also equal to V naught equals K times the concentration of the enzyme times the concentration of the substrate all over Km. Because we know we solved for the enzyme substrate concentration. And so we're just substituting that in every time we see it. So that's what we did right here. So to do this, we'll need to rearrange the E total concentration equation to solve for the concentration of free enzyme. So the concentration of free enzyme, when we rearrange, is equal to E total all over 1 plus the concentration of the substrate over Km plus the concentration of the inhibitor over Ki1 plus the concentration of the substrate all over Km times the concentration of the inhibitor over Ki2. So after doing that, we can plug the equation for the concentration of free enzyme into the V naught equation. So we take this, since we have a value of the concentration of free enzyme, and we can plug that right up into here. And so what that will give us is V naught equals K times the concentration of E total times the concentration of the substrate all over 1 plus the concentration of the substrate over Km plus the concentration of the inhibitor over Ki plus the concentration of the substrate over Km times the concentration of the inhibitor over Ki2. And then all of that is multiplied by Km because we already had a Km in the denominator. So from this equation, we also know that V max equals K times the concentration of E total, which we have right here. So we can substitute V max in for that. And then we can further simplify the denominator by distributing this Km. So once we do that, we get V naught equals V max times the concentration of the substrate all over Km plus the concentration of the substrate plus Km times the concentration of the inhibitor over Ki1 plus the concentration of the substrate times the concentration of the inhibitor over Ki2. So now we can factor out certain variables from each part of the denominator. And as you'll see, I factor out Km for this first part, and then I factor out the concentration of the substrate for this second part. And that will give us Km times 1 plus the concentration of the inhibitor over Ki plus the concentration of the substrate times 1 plus the concentration of the inhibitor over Ki2. And of course, that is fit into the equation for V naught, where that is under V max times the concentration of the substrate. Furthermore, we also know that alpha is equal to 1 plus the concentration of I over the Ki, and that alpha 2 is equal to 1 plus the concentration of I over Ki2. And we can see both of these values for alpha right here and here. So if we just plug alpha into where, and alpha 2 into where those are, we get V naught equals V max times the concentration of the substrate over Km times alpha plus the concentration of the substrate times alpha 2. And there we have it. We have successfully derived the equation for mixed inhibition.